Farmers face key decisions every day. Every choice, from when to irrigate to how much fertilizer to apply, can impact yield, profitability, and sustainability. In the Alabama TAPS competition, 8 teams put those decisions to the test, managing a crop using real-world data throughout the growing season. With each team taking a different approach, the competition highlights how management strategies influence performance and ultimately determines whose strategy comes out on top. We are 57 days after planting, and through the week of June 2nd through the 8th the corn has been in the V15 growth stage, with very few plots beginning to tassel. At this growth stage, the corn uses around 0.18 to 0.20 inches daily. The corn must receive water at this stage because it is moving towards the peak water demand. Looking back at this past week, we caught a nice break with 1.28 inches of total rainfall represented by 3 events not evenly spaced. On the temperature side, we saw some classic early summer swings. Daytime highs climbed anywhere from 81 to 90 degrees, while our nights dropped between 55 and 71. Because nature did the heavy lifting, we didn't have to trigger a single scheduled irrigation event this week. The water demanded by the crop came straight from the rain. Tracking these exact shifts is exactly how we keep from overwatering, ensuring we only pull the trigger on irrigation when the data says the crop truly needs it. Next, we'll look at the AquaSpy Soil Moisture Probe, one of the tools available to teams in this year's competition. If you have questions about the probe or how to interpret the graphs, be sure to check out our first video for more details. Looking at the data from June 2nd to June 8th, available soil water stayed relatively high thanks to the significant rainfall received the week before. As the crops continued to use water, soil moisture gradually declined throughout the week. Then, on June 7th, a 0.66-inch rainfall event replenished the soil profile. The 0.66 inches increased soil moisture mainly in the top 24 inches depth, close to 80% soil available water. The second tool available to our teams to help manage irrigation is the free CropFit app, developed by the University of Georgia. It can link directly to various types of automated weather stations. For our setup, we've linked it to our Davis rain gauge to pull real-time rainfall data. CropFit is designed to help southeastern row crop farmers pinpoint exactly when and how much they need to irrigate. When you set up or add a field in the app, the tool automatically pulls data from the NRCS database to calculate the exact soil characteristics and water holding capacity of the main soil present in the field. As you can see on the screen, on June 2nd, the app showed a 0% soil water deficit, meaning the profile was completely full and there was no need for irrigation. Generally, we don't recommend triggering irrigation unless the soil water deficit crosses the 50% depletion mark prior to tasseling. This threshold changes to 40% if the corn is at the early reproductive stages. By June 7th, a rainfall event of 0.66 inches was recorded, which contributed to increasing the soil moisture and reducing the deficit at a comfortable 3% and allowing us to keep the irrigation system turned off. Another soil moisture tool used in the study is the CropX Soil Sensor Probe, which was generously donated by one of our sponsors. The CropX system provides real-time measurements of soil moisture at multiple depths throughout the crop root zone, or profile. Its profile sum helps simplify interpretation by dividing soil water status into 3 management zones. The optimal zone, which supports healthy crop growth, the full zone, which indicates excess moisture, and the refill zone, which signals when irrigation may be needed. These thresholds can be manually adjusted by the user or automatically calibrated by the CropX system once the probe is installed in the field. By understanding how moisture changes over time, growers can improve water management and help maintain optimal conditions for crop growth. A useful feature in CropX is the ruler tool, which allows you to quantify the rate of available water loss directly from the soil moisture graph. By highlighting a selected period on the graph, CropX automatically calculates the depletion rate. In this example, following a rainfall event from June 2nd to June 3rd, the ruler tool shows a rapid decline in available water, with a loss rate of approximately 3.2 inches within the profile sum, which is the total moisture measured across the entire depth range of your sensor. For additional information or questions regarding irrigation scheduling, please contact Dr. Brenda Ortiz with Auburn University and the Alabama Cooperative Extension System.